Past the orbit of Neptune lies a freezing, remote stretch of deep space known as the Kuiper Belt. For decades, planetary models painted this region as a collection of ancient, unchanging relics. Looking at this image of Pluto, we see the traditional exception to the rule. It was long understood that in the extreme cold of the outer solar system, only the most massive bodies possess the gravitational pull required to lock down an atmosphere. On smaller worlds, a process called Jeans escape takes over. Even at 40 Kelvin, the thermal energy of gas molecules is often sufficient to overcome a small object's weak gravitational pull, causing primordial gases to bleed away into the void. By these rules, any non-giant object at the solar system's edge was categorized as a frozen, inert body. That model held until a team of Japanese astronomers pointed their instruments at a small chunk of rock and ice 4 billion miles from Earth, formerly known as 2002 XV93. This chart gives a sense of its scale. Measuring roughly 500 kilometers across, the object is about the size of Pennsylvania, or 1/7 the width of our moon. Despite its size, this world possesses a global, gravity-bound gaseous envelope. The surface pressure is calculated between 100 and 200 nanobars. While tenuous, this pressure is 50 to 100 times higher than previous upper limits established for much larger objects like Eris or Makemake. The existence of this gas on such a small body contradicts the traditional models of how volatiles are retained in deep space. Direct photography of an object this small and distant is currently impossible. To find the atmosphere, astronomers had to rely on shadows. On January 10, 2002 XV93 drifted perfectly in front of a distant 15th magnitude star in the constellation Auriga. This graph shows the expected data for a dead rock. If the object were airless, the starlight would drop instantly to zero as the solid edge passed in front of the star. Instead, high-speed cameras captured a gradual, smooth fade and recovery lasting 1.5 seconds. This smooth dimming indicates that the starlight was actively bending and refracting through a layer of gas before the solid body of the object ever reached the line of sight. Analysis of those 1.5 seconds of refracted light provided the first definitive evidence of an atmosphere on a small trans-Neptunian object. This creates what researchers call the Volatile Paradox. Massive objects like Eris and Qualar have the required gravity to hold an atmosphere, yet they appear completely bare. 2002 XV93 is the isolated underdog, a world with a fraction of the gravity of the giants, yet wrapped in a global envelope of gas. Because this gas should eventually escape into space, there must be an internal process actively replenishing the atmosphere from within the object. One theory suggests a warm interior driving geological activity, where internal pressure vents gases through cracks in the crust, effectively acting as ice volcanoes. Another possibility is a recent large-scale collision that vaporized surface ices, temporarily surrounding the world in a shroud of vapor. These potential mechanisms characterize 2002 XV93 as an active system that continues to generate enough internal energy to resist the deep freeze of its environment. The scientific community is currently re-evaluating its atmospheric models, as the data from 2002 XV93 suggests our understanding of gas retention on small bodies is incomplete. The discovery also marks a shift in how these objects are studied. While major observatories lead the research, data from a 25-centimeter amateur telescope in Fukushima was used to help confirm the findings. Following the announcement, the James Webb Space Telescope is expected to allocate time for deep spectroscopic integration to identify the specific chemical composition of the air. Proving that such small bodies can maintain gas envelopes strengthens the scientific case for proposed flyby missions to explore these active environments up close. The discovery reframes the Kuiper Belt as a region containing active geological systems and the chemical building blocks for life. There is a unique significance in the data: a 500-kilometer rock, isolated in the absolute dark, consistently releasing gas into space. This suggests the outer solar system is populated with geologically diverse bodies, contrasting with the previous model of a vast empty void. The core takeaway from 2002 XV93 is that sheer scale does not dictate geological complexity or the scientific value of a world. It indicates that our fundamental maps of dead space have missed key signs of activity for decades. If an object of this size can sustain an atmosphere, it points to a solar system filled with hidden, active worlds waiting.
An investment in knowledge pays the best interest, so why not invest in this channel? Click like and subscribe for more.